Hey there everyone, this is Jeet, your best friend in programming, and I'm back again with another tutorial on Electron. In this tutorial, we will learn how to use and connect with a MongoDB database in Electron. So let's get started. MongoDB is a NoSQL database. That means unlike an RDBMS or a relational database management system, the collections or tables, you can interpret them as tables too, do not have relationships. Instead, the collections are actually collections of documents, and each document has all the information you need to process and work with the data. MongoDB's syntax is quite like JSON. So when you read it, when you read the database structure, it's going to look just like JSON. And in fact, this is stored in a form of JSON which is called binary JSON. Due to its unique structure, MongoDB is very suitable for things like blogs, accounting software, or any kind of data, any kind of app that expresses its data in form of individual documents. Alright, so let's get started and see how to get it working with Electron. Before we do that, I want to tell you one thing more. MongoDB is a server-based technology, kind of like MySQL or SQL Server, and it will not be portable. So if you're trying to ship your Electron app and you want to contain the database, you want to package the database with your app, that's not going to happen because MongoDB requires a server to run. So on your target computer, you will either need to install the MongoDB server, or you will need to put your database on an online server and then connect to the online database. With that out of the way, let's get going. Before we can connect to MongoDB, we need to install it on our computer. We can do that by searching for MongoDB Community Server. Just like the MySQL Community Server, this is an installable version of MongoDB that you can put on your computer, and typically this page will have the server or the download configured for your computer. So we are downloading the latest version, which is the current version. It might be different for you depending on when you view this tutorial. I'm on Windows, so I'm getting Windows by default. You can choose from a number of different OSs based on what you're working on. And then I want the MSI because that's the installable file. Click on download and it will be downloaded to your computer. Here's the downloaded file. Run it and you will see the installer on your screen. Just go for the default options. It's fine. Click on complete. If you want to change the directory, that's okay. Click on next and then on install. It can take some minutes. Once the installation is finished, it will automatically load up the MongoDB Compass, which is an app that will help you use MongoDB through the online interface. And you will also see the URL for MongoDB. So it's typically installed on localhost with the port 27017. And this is what you need to use in the connection strings, which we'll talk about soon. For now, click on the connections in the sidebar to connect to that server. Now you can see the databases on the server, and these are the default databases of MongoDB. For our use, we'll need to create a new database for our test. Let's call it employee data. And we can also create an initial collection called employees. Click on create database, and here we have our employee data database. Click on it and you can even see our first collection, but right now it's totally empty. MongoDB also has an inbuilt shell that you can load, and you can use this shell to work with the database. You can see the detailed documentation of how the driver works from the MongoDB documentation for Node.js. Just search for it and you will find it easily. Remember, Electron is actually built using Node.js, so this documentation is perfectly applicable to Electron too. MongoDB driver has a number of functions that can help you do things like collection find one, which just finds one object. You can find multiple objects using find. You can insert a new document using insert one, and you can insert multiple documents using insert many. There are functions to update and also to replace or delete. So we'll be using all of these functions in this code base, and we have created a special class that you will see soon that has reference to all these functions. It's actually a model class. A model class is a class that handles the backend of the database and exposes the database functionality in a way that is more logical. If you want to understand more about model classes, you can Google that and learn about it. Now let's go to Electron and find out how to connect with the database and work with it. This is my Electron boilerplate app. The project structured just the way I like it. I also have NodeMon configured, so the app will auto reload when running if I make any changes. If you want this boilerplate, you can find it on my GitHub profile. Now we need to install MongoDB to this project, so we can find it on npm.js. Let's look for MongoDB. And here we've got the official MongoDB driver for Node.js. This is what we'll use for Electron 2, because remember, Electron is based on Node. So click here and you can just copy this command npm I MongoDB, or you can just type it in the terminal. To load the terminal, we can go to terminal and new terminal. It will load a new terminal, and then we can just write npm I MongoDB. Alright, so now MongoDB is installed and we can use it in this project. This little app that we're going to build is an employee manager app. You can put in name, position, salary of employees and review them, and if you want you can delete records or edit them. This app is going to be great to learn the CRUD, create, update, delete functions of Mongo. So let's get started right away. Let's write the interface first. We're going to use HTML5. Let's set the title to employee manager. And for the CSS, we are not just gonna use the standard CSS, we are gonna use the library. And the library I like often to make Electron projects is Bulma. It's quite simple to learn and it works very well, so I prefer that. So we're gonna use Bulma over here, and then we can create the sections in the project. So the first section that I wanna put in is the main section, which is going to be the entry form for this project. And what you've got here is a name input box, and I've got it nicely laid down with a class input, type text and ID name. Then you've got a position, the employee position. It's again a text type input box, and then you've got the salary of this person, which is also a text type input box. Now I have a hidden input over here called employee ID or emp ID, and the reason why I have this is because I want to be able to distinguish when we are actually updating a record and not creating a new record. You see, whenever you save an employee data, you want to make sure that you know whether you want to create a new employee or update an older one. And to do that, typically we use a unique identifier, which is also called a key, a primary key or an ID, and that's what this is going to be. If this ID is set to something, we're gonna look for a value with that ID and update the record. Otherwise, we will create a new entry in the employee document set. Then you've got two buttons called get employees, which will load all the data from the database, and save employee, which will save the current information in this to the database. And after that, we also need to have a little bit more. I will just put it here. This is a table to display the records in our database, and it's got just 4 fields: name, position, salary and actions. And then I've got a T body with an ID TB employee, so we're gonna fill that with the table data. And finally we're gonna have a reference to our view file. Now I told you earlier I have a preferred boilerplate of doing things, and in my boilerplate each screen will have a HTML file associated with it, and then it will also have a preload file, a backend process file, and also a view file which will be in the render process. Let's see this in action. Okay, so you can see the interface in action. We've got the title over here, the 3 input boxes, and there is an input type hidden which is not visible. You've got the 2 buttons over here, and if you click get employees, you actually get the data which is already there in the database. Now let's see how this works. The main HTML file has a reference to the main view file, which will be loaded when the HTML file is completely loaded. It's right at the end. And in the main view file, we will write the code to handle some events. So for that, we're going to use the window add event listener load event. Now window, of course, is the topmost object on the browser, the window object. And when the page is completely loaded, then you want to connect the events. And our event handlers are pretty simple. We have 2 buttons. One is called the button save. we'll call it button save, and we're going to use document.getElementById. If you remember, the buttons here have the ID button get and button save. So we are getting a reference to the button save button, assigning it to the constant button save, and then we are adding an event listener to this button using btnsave.addEventListener, and this is the event actually that we are trapping, the click event, and we will create a function called button save click. Similarly, for get button we have btn get over here, and then we are assigning an event listener called btn get click. Here is our btn get click function. For now, let's comment the btn save button. You can see it's pretty easy. We console log get button clicked, and then we do event.prevent default. If you don't prevent the default behavior of this button, the page will reload. The browser will submit and the page will reload, and we don't want that. We want the page to remain static, not to reload. That's why we're calling event.prevent default. And then we've got a line that says windows.api.getEmployees. Now, where did this come from? Well, this is the context-rich system of Electron, and you can connect the preload functions right over here to the view using the context bridge. So I have an object in my preload called API, which has a function called getEmployees, and that's what I'm calling over here. And next we will set up our preload file and see how that's gonna work. So here we have our main preload.js file, and that's the file we are referring to in the main screen.js. You can see the preload is set to main preload.js. So that's where this is coming from. In main preload.js, the first line you want to be should be const context bridge, IPC renderer, in case you want IPC communications. And if you want to learn IPC communications in Node.js, I have another video on it. You can find it on my channel. So go ahead and check it out if you want to know more about that. Then you require electrons, because these objects are coming from Electron. Next, we want to check out the context bridge itself. So a couple of spaces, and we have context bridge dot expose in main world. That's the command we use to bring something to the window object of the browser. So anything that you expose to the main world will be available in main view in window object. So I have specified here exposing main world, and I'm calling this object API, and whatever I put in this object will be available here. So you can see there is a function called getEmployees. So let's just get it and put it in the preload right now. Here we have the getEmployees function, and let's also put it in the main world like this. So now getEmployees is exposed to the main world, and you can call it from main view. But now let's look at getEmployees. How does it work? So the first thing is, of course, a console log. We want to see that there was indeed a call to this function, and this kind of console.log will ensure that. Then we are calling an employees object. We are actually calling employees.getEmployees, and then is a promise. When this promise is resolved, then got employee callback. So we are also using callbacks. Now where is all that coming from? So let's put in that code. The first thing I want to put in over here is a call to globals. Const globals require globals, and if you look at my globals file, it's nothing, just a place where I put in my constants and I have exported them. So the first thing is the URI. This is the MongoDB connection string and the database name, what database I want to connect to in MongoDB. So we're going to use this later to connect to that database. So the next reference I want is to the actual models where I handle the database, where we connect to the database and we do all the calls, and that is employees.js in the models folder. And I will explain what exactly is going on over here as we construct it in a bit. So in the preload we have globals and employees, and the employees object right over here is an instance of the employees class. So let's just put in this line, and this will make things quite clearer. So you've got an employees object over here, which is an instance of the employees class, and we are passing globals.uri, the MongoDB connection string, and the MongoDB database to this employee class, and the employees model class is connecting to this database to work with it. And now we are in employees.js. It's empty right now. Let's fill it up. The first line that you need to put in is const mongo client and you use require mongodb. We just installed that a little while ago, so you can use require mongodb and refer to mongo client. Next is const object id. So object id is a unique identifier in every Mongo document and we will use it later, so we'll just get an instance of that. And then let's start constructing our class. So we've got a class called employees and it has got two fields, db name and client. So when we create the constructor for this, we will be passing the URI right from the preload file, globals.uri, globals.db name. That's what we passed, the URI of the database and the database name, and we created a new instance of it using the Mongo client object. So all that is done, and if you close it over here, you've got a basic working class, but right now we are not doing anything with the database, so let's just start to do a little bit. The first function I want to create is called get collection, and this is a private function. So whenever you see hash in front of a function name in a class, that's a private function, and this function is called get collection. What it does is get the collection from the database that you want. In our particular database, we have only one collection. So this is Mongo Compass, MongoDB Compass, which is a front end provided by MongoDB to work with the MongoDB databases. I've shown it to you earlier. I've got a database called employee data, and in that I've got a collection called employees. That's what this gets, and we will use this in nearly everything that we do in MongoDB, because before you can work on a collection, you need to get a reference to it. So let's also create the get employees function, which was the function that we need to show the employees data. This is the get employees function. We are creating a console log. We are writing some information to the log, and then we are getting the collection using the get collection function over here. And then we are using the MongoDB find command to find all the records in the database, and we have to convert it to array. If you don't convert it to array and we send it to the view, the object will not be readable by the view. You need to have proper JavaScript objects. So convert it to an array. But that's not all. Now the object ID over here is an interesting kind of an object. If you send it to the view using toArray, it will be converted to a buffer, to a uint8 array buffer type, and converting that to actual string is pretty difficult. Look at this. This is how the object ID looks. This is the actual object ID, and if you get an array buffer, you will need to convert it manually, which is tricky. But MongoDB has a very helpful function called toHexString to convert it to this human readable format, and that's what we're gonna use. This array that we have here, we're gonna call map function again on it to convert the ID object, the underscore ID object, to a proper readable ID. So this here is an object ID, and you are converting it to a hex string and assigning it to the ID object. At the same time, I'm also getting the name, the position, and the salary data points from the database. Finally, I'm just logging it and returning it. And before we can use it in the other module, we have to write module.exports employees. So we are exporting the employees class from this module, and now it's available to preload. So let's run our code and see if that works. Here we are, and if we click on get employees, we got a big fat error because we also need to set the callbacks. You see, all of the data that we get here is actually promises. So this employee.getEmployees then is a promise, and it needs to refer to a callback to resolve that promise, right? Because we are not using await over here. So let's create this callback function too. So this callback function is called getEmployees, and we are referring to it in getEmployee callback. So we will need to create a variable that holds this too. This is the variable that holds the callback function getEmployees, and we will need to export it in our context bridge. Okay, let's close this. Let's not keep this running. And we also need to refer to it in the view itself. So let's do that too. Let's create a section called callbacks, and then we are referring to it windows.api getEmployees got employees. This is the callback function, and we need to create a function that gets passed into the callback. So we need to create a function called got employees 2, which decides what's to be done with the data that we get. So let's create the function got employees over here, and now the callback is properly set up. So let's run it now and let's see if this works. Here we go. Alright, so we are getting the data from the database, as you can see. And if we come to the Compass instance, MongoDB Compass, this is the data we have here, and we are retrieving it successfully to the Employee Manager app. Let's take a look at our callback function and see how it works. We've got employees over here, which is a callback, and you get the employees array passed to this. Remember, this is the employees array we got over here. That's the array that's passed over here, and then we are mapping this array to some HTML code. There is a table row, and we have different table diagonals, different table cells with the name, position, salary, and we also have two buttons. One is a delete button and the other one is an edit button. These are functions too, and we are passing the employee ID that we got in the array to these two functions. We'll create these two functions to create the delete and the edit functions of this app. Now let's also create the save employee system. So we need to create a system to create new records in the database. Let's do that next. For the edit function, we will need to identify which record we are referring to, and that's why we have kept a record of all the employees in the employee data variable over here. Let's also declare it at the top so that it can actually work. And in employee data, we are getting a list of all the employees. We are keeping a list safe. And now let's see the edit function in action too. Let's create it. Here we got the edit function. What it does is it will find the employee that you are referring to when you click the button, and it will fill the data in the input boxes referring to that particular employee. So you will get that employee's name, position, salary, and it will assign the employee ID to the hidden input that you have on the main page. Remember this? This is where the employee ID is stored, and that is a unique identifier that we need to edit the employee. Right? So that's what's happening over here. We are assigning the value of each item to the employee record that we just found from here over here. This loads the employee, but how can you actually save the data? For that, we need to have a save function also, and I have it with me. I'm going to show it to you and show you how it works. Right over here, let's create button save click, and you can see in button save click again we are doing event prevent default to prevent the form from submitting, and then we are getting the name, position, salary and the employee ID using get element id dot value for each particular field, including the employee ID. And then we are checking if the employee ID is empty or not. Now, if this is the new record, the employee ID will be empty because you are not editing an existing record. So there is no employee ID for the particular person. And you will call window.api save employee, which is a function which is present in the preload file, and pass it the details of the person. But if there is an employee ID existing, you will update the existing record, and then we will pass the employee ID as well as the new information. So let's do that. Let's create these functions in main preload and follow up from there. Here we are in main preload. The first function we want to create is save employees. It's very simple. We are calling employees.addEmployee, and in employees, if you go to that particular class, we will need to create an add employee function too. And here we got the add employee function right over here. So in add employees, all we're doing is getting the collection and then calling the MongoDB insert one function to assign the employee document and add the employee document to the collection. Pretty simple stuff, right? Similarly, we also have an update employee function too, and in this particular function what we're doing is we're using the update one function, and we are using the unique ID that we got. We are creating a new instance of the object ID, and we are passing it the hexadecimal ID that we have to create a new ID object, and then we are setting this particular object to the new employee object that we got as a part of the argument which was passed. We will need to also create an update employee function over here too. Here we got update employees, and then we also need to create two callbacks, and then we also need to create a callback connected to update employee called got employee updated callback. So let's create that callback too. Here we've got, this will keep the result whether the update function was successful or not. And we also need to declare this callback in a variable at the top. Let got employee updated callback. So all of that is done, and now we can take the update employee function to the context bridge. We will also need to take the save employee function to the context bridge. Let's put it over here. And we will also need to take the callback to the context bridge too. So right over here. And in the view, again, we need to connect the callback. So let's go there to the view. Window.api.getEmployeeUpdatedResult callback. And we also need to write the getEmployeeUpdatedResult function too. So we already have it over here. And if the employee details were updated, we just get the list afresh. Now let's see if that works. Alright, so it's running. We can get employees, and that's working. If you click on edit employees, you will see that the data is now loaded over here. Let's just remove one digit and click on save employees, and then click on get employees again, and you can see that this didn't work at all. The reason why this happened is pretty simple, because we had commented the save button code earlier and we didn't uncomment it. So it should work pretty well now. Get employees, and if you click on edit employees, you can edit it, and when you click on save, okay, you can see that the number actually changed. I'm gonna just remove the debugger that I put in while I was testing. Save it again. Here it runs. Get employees. You've got 3000 over here. Click on edit. Let's make it 5000 and click on save. So you can see the data is changing now. We are able to save. Now let's create the final thing, that is the delete command, and it's also quite easy. Again, we'll start with the front end. Let's put in the delete function right over here. And the delete function is quite simple. You're calling only one command called delete employees in the preload. So the next we have to put the delete command in the preload, and we've got it right over here, delete employees. And you can see we have another callback, got deleted results. So when there is a result to the delete function, this is the employees.delete employee, which we are calling in the CRUD class, in the model class. So we need to have a callback. Let's create that callback too. Got employee updated, that's the wrong one. Got employee deleted callback. So that callback is now covered, and we need to expose both these functions in the main world. So got delete result, that's the callback, and got and delete employees, that's the actual function. So both of them are exposed. We haven't finished yet, so let's close the auto run. So we got deleted results and delete employees too. Then we need to put the delete function in the employees class, and let's see how that is gonna work. Pretty easy, just a single call to delete one method of MongoDB. Alright, now that we've written everything, just save it and let's try to see if that works. Again, npm run watch. It's running, and you've got an error right over here. Get deleted result is not defined. So something is missing yet. Got deleted result, the callback function is missing. So we need to put that in our preload. Got deleted result, and it's already exported. Let's run again. This time there's no error, and if we try to get employees, we are getting them. And let's try deleting this guy. Nothing happened. The record was actually deleted, but we didn't see it because we didn't have the correct callback function set up in the view. So we need to declare the callback function right at the top to connect it, and then we need to also create the got delete result function. So let's just do that. We'll put it here. Pretty simple function. All we're doing is showing a message, record deleted. Let's run it now. Get employees. We got some records. Let's try deleting. And you can see record deleted. And if you click on get employees again to refresh the list, you can see that it's gone. And let's just remove the debugger, run it again, and we will see it again in action. Delete, and that's working right away. That brings us to the end of our tutorial. Remember, all of this code is available to you in a GitHub repository. There is a link in the description, and you can go through this code to understand how MongoDB works, and you can build your complicated applications using the same system. This application is made to be scalable, and this prototype is built to be used as a fundamental project for a more complicated application. We have a model class 2 for the database, and I think it deserves another look. We've got a class called employees where we are accepting the database name and the client, and we are creating a constructor. We have a constructor here where we are accepting the database connection string and the database name, and we are opening it using get collection. Anytime we call get collection, the database collection will be referred to and you will get a reference to it. And then you can use standard MongoDB functions like find, like insert one, like update one, like delete one to work on the database. But remember, we are not exposing these functions directly. We are abstracting them in logical functions like add employee, update employee, delete employee. So the functions that we call from the app will be functions like delete employee, not delete one. So you can have this abstracted and represented logically in the app, and every collection that you create in your database will have a CRUD class, a model class, just like this one. I hope this tutorial was useful to you. If it was, don't forget to give it a like, a thumbs up, comment, tell us what you think about it, and also subscribe to this channel because I'll be coming back to you with a lot of videos on programming. This is Coder Jeet, your best friend in programming, signing off.